Imagine this. You're chilling on a planet with not one, not two, but 3 suns in the sky. One day it's a balmy summer. The next, you're flash frozen in eternal winter. And before you know it, everything's on fire. Sound like a nightmare? That's the hook from Netflix's hit series, 3 Body Problem, based on Liu Cixin's epic novels. In the show, an alien civilization on Tri-Solaris battles this insane chaos, where predicting the sun's movements is impossible, leading to civilizations rising and falling in endless cycles. But here's the kicker. This isn't just sci-fi fluff. It's rooted in real physics, and it might explain why our own solar system's outer edges could one day send a cosmic curveball straight at Earth. Today, we're smashing together 2 wild concepts, the 3 Body Problem and the Kuiper Belt, to uncover how billions of icy rocks out there dance in unpredictable ways, making it mathematically impossible to say for sure if one might slam into us. Stick around, because by the end, you'll know how this chaos shapes our universe, with real-life examples, Hollywood twists, and tips on what scientists are doing about it. Let's blast off. Let's break down the 3 Body Problem without making your head spin like those Trisolaran suns. Picture this. In our everyday world, gravity seems straightforward. The Earth orbits the Sun in a neat ellipse, predictable down to the second, thanks to Isaac Newton's laws from the 1600s. That's a 2-body problem. Sun and Earth. Easy peasy. We can calculate where they'll be 1,000,000 years from now. But toss in a 3rd body of similar mass, say another star, and boom, chaos ensues. No simple equation can predict their paths forever. Why? It's all about sensitivity. Tiny differences in starting positions or speeds grow exponentially over time, like a butterfly flapping its wings and causing a hurricane. This is deterministic chaos. The rules are fixed, but the outcome? Wildly unpredictable. Remember that scene in 3 Body Problem where the aliens simulate their world's orbits in a virtual reality game? The 3 suns whirl around, sometimes aligning to scorch the planet, other times flinging it into the cold void. That's a direct nod to the 3 Body Problem, first puzzled over by mathematicians like Henri Poincaré in the late 1800s. He proved there's no general analytical solution, just special cases like stable figure-8 orbits or Lagrange points where things can hang out peacefully. But in most scenarios, one body gets ejected or they collide in spectacular fashion. Real-life example. Our Moon-Earth-Sun system is a mild 3-body setup. It's mostly stable, but over billions of years, tiny chaotic wobbles could shift things. Another real-life example of the 3-body problem is the Alpha Centauri system. It is a triple-star system in which predicting the precise future paths of its 3 stars is fundamentally impossible. This system is located approximately 4 light-years away from our solar system. We've seen this in binary star systems with a 3rd interloper. Astronomers observe stars getting slung out at high speeds like cosmic billiards. Now zoom out to the Kuiper Belt, that vast, donut-shaped frontier beyond Neptune, starting at about 30 times Earth's distance from the Sun and stretching to 50 or more. It's like the solar system's junk drawer, packed with billions of icy asteroids, comets, and dwarf planets like Pluto and Eris. Think of it as a frozen time capsule from the solar system's birth 4.5 billion years ago. NASA's New Horizons spacecraft gave us our first close-up in 2015, flying by Pluto and revealing craters, mountains, and even a heart-shaped plain. Then, in 2019, it buzzed Arakoth, a weird snowman-shaped rock that's basically two blobs gently smushed together. Proof of how planets formed through soft mergers, not violent crashes. Most distant world ever explored gets new name: Arakoth. But the Kuiper Belt isn't a quiet graveyard. It's buzzing with activity, thanks to gravitational tugs from Neptune and other giants. Objects here zip around in orbits that can last thousands of years, but close encounters or resonances, where orbits sync up like dancers, can destabilize them. Real-life drama. Comet Hale-Bopp in 1997, which lit up our skies, likely originated from the Kuiper Belt or its scattered disk extension. It got perturbed inward, giving us a spectacular show, but reminding us these things can wander. Here's where we fuse the two ideas. The Kuiper Belt is essentially a massive n-body problem, where n is billions. It's not just three bodies, it's the Sun, planets, and countless KBOs, Kuiper Belt objects, all pulling on each other. The three-body problem shows us the base chaos with three players. Scale it up, and predictability vanishes. Mathematically, we can't solve for every orbit exactly because of that exponential sensitivity. Supercomputers run simulations, like those from the Nice model, which explains how giant planets migrated early on, scattering KBOs everywhere. But even those models are probabilistic. They tell us trends, like how 1% of scattered disk objects might leak inward over eons, but not which specific comet will head our way next. Visualize this with a Hollywood flair. In Armageddon, 1998, Bruce Willis and his crew drill into a Texas-sized asteroid barreling toward Earth. That rock? In reality, it could mimic a Kuiper Belt object gone rogue, perturbed by Jupiter's gravity in a multi-body dance, slinging it inward like a slingshot. The movie's over the top, with explosions and heroism, but the core fear is spot on. Unpredictable orbits from distant belts could doom us. Or take Don't Look Up, 2021, where a comet discovered by astronomers is on a collision course, but society ignores it. That comet's path echoes the chaos we're talking about. Small nudges in the outer solar system could redirect it years before we spot it. Real-world tie-in: the Chicxulub impact 66 million years ago, which wiped out the dinosaurs, might have been a comet from the outer reservoirs like the Kuiper Belt or Oort cloud. Evidence from iridium layers and the crater in Mexico points to a 10-kilometer object smashing in at 20 kilometers per second, triggering global fires and a nuclear winter. Was its path chaotic? Absolutely. Likely scattered by Neptune or Jupiter in a three-body-like interaction millions of years prior. We can't rewind the clock to predict it exactly, but simulations show such events happen every 50 to 100 million years. Diving deeper, consider Planet 9, that hypothetical super-Earth lurking beyond the Kuiper Belt. Astronomers like Mike Brown and Konstantin Batygin propose it to explain why some KBOs, like Sedna with its 11,000-year egg-shaped orbit, cluster oddly. If Planet 9 exists, 5 to 10 Earth masses, it's hurting these objects gravitationally. But add it to the mix, and the three-body problem amps up. Sun, Neptune, Planet 9 pulling on KBOs creates even more chaos. One nudge and a comet flock could cascade inward. In The Expanse TV series, the belt, asteroid belt, but analogous, is a lawless zone where gravitational politics play out. Ships slingshot around planets, mirroring how real KBOs could get flung. How do we handle this uncertainty? Space agencies track near-Earth objects, NEOs, with telescopes like Pan-STARRS and the upcoming Vera Rubin Observatory, set to spot millions more by the 2030s. We've cataloged over 30,000 NEOs, and none pose an immediate threat. But for Kuiper-sourced comets, they're icy and dark, harder to detect until close. NASA's DART mission in 2022 successfully nudged an asteroid, proof we can deflect if needed. Future probes like the European Space Agency's Comet Interceptor aim to study incoming comets up close. Think about meteor showers, the Perseids or Geminids. Many stem from comets that were once Kuiper residents, fragmented by chaos. In 1910, Halley's Comet, from the scattered disk, caused global panic. People thought its tail would poison Earth. It didn't, but it shows our fascination with these unpredictable visitors. Wrapping up, the marriage of the three-body problem and the Kuiper Belt paints our solar system as a dynamic, chaotic symphony rather than a clockwork machine. Billions of objects out there, influenced by multi-body gravity, mean we can't predict every threat. But that's what makes space exploration thrilling. From the fictional horrors of three-body problem to the real extinction of dinosaurs, this chaos has shaped life on Earth. So, what can you do? Support space funding. Stargaze with apps like Sky Safari. Or join citizen science on Zooniverse to classify asteroids. Who knows? Your observation might spot the next big one. If this blew your mind, hit that like button, subscribe for more cosmic deep dives, and drop in the comments what's your favorite space movie and why. Thanks for watching. Stay curious, and see you in the next orbit.